This is the day 20 video on growth and decay models. And in class we talked about, we looked at actually t-charts with some values of x and y, and we found out the formula based on those charts. So here we have time and we have bacteria population. So what were the two things that we talked about in class that you need to find out before you can write the equation? What were those two things? Hopefully you're thinking right now, I think we had to know where it started, the initial amount. We also needed to know what. So here our initial amount, when x is 0, y is 100. So our initial amount is 100. We started with 100 bacteria. And then we also need to know what. What was this? Good. You should have said the rate. We also need to know the rate at which it's increasing or decreasing. Okay, so the rate here, each time we're multiplying times 2. Times 2. So we could continue this table if I continue times 2 each time. We could fill this in. 400 times 2, 800 times 2, 1600 times 2, and so on. But then it says n. Oh goodness, there's not supposed to be a 3200 here. That's a dot dot dot. Okay, so what if I wanted to write an equation that represented any value, any time value? So I'd say, okay, well, I started with 100, and then each time, this was 100 and times 1, maybe. And this was 100 times 2. And this was 100 times 2 times 2 again. And this was 100 times 2 times 2 times 2. So if you notice, each time our power of 2 is increasing, and it's actually to the same power that our time is. So this is 2 to the 1, this is 2 squared, this is 2 cubed, and this would actually be 2 to the 0, right? Because anything to the 0 power is 1. So if I wanted to write that in an equation, I could say, okay, well, 2 to the nth power. And that's going to give me any value, at any time I can figure out how many bacteria there would be. All right, so our equation then would be 100 times the rate, and it looks like it's doubling each time, to the power of, now there's a couple options. We could, here it says n, we could put t, we could put x, depending on what the situation is or what we're talking about. Here it just says n, so I'm going to say equals bacteria. All right, so that would be writing the equation after n hours. All right, so I think you guys can do this. There's a couple things we need to consider with this every 30 minutes, so we'll talk about that. But predict the population of bacteria for each situation in each time period. So we need to know how many initially were there. 55 bacteria initially, and it doubled. So this is important. This tells me the rate. My rate is times 2 to the power of something, and every hour. Okay, so my equation would be the number of bacteria equals the initial amount times 2 to the power of h. Why am I using h? Yes, because every hour. So h hours, h represents the number of hours. All right, so after 3 hours, well, I'm going to plug in 3. So 55 times 2 to the third power is going to give me the number of bacteria. Now I need to do my power first. 2 to the third power is 8, and 8 times 55, and that's 440 bacteria. So after 3 hours, there are 440 bacteria. Now I need to write that bacteria because, am I talking about 440 hours? I need to make sure that it's clear what am I talking about. After 5 hours, so again, I just plug in. You guys find this. Tell me how many bacteria after 5 hours. Go ahead and hit pause real quick. Check it, figure it out, and then hit play. And you should get 1,760 bacteria. Now, if you didn't write bacteria, that would not be completely correct. You need to make sure you write this whole thing here. Okay, I'd like you to hit pause right now. I mean it. I want you to hit pause. I want you to try, oh no. I lied, I'm sorry. Okay, 33 bacteria. We need to talk about this every 30 minutes. So if we think about every hour, how many 30-minute periods are there? 1, 2, 1, 2, right? So in every 1 hour, there are 2 30-minute periods. So this is saying that I start with 33, but then I double every 30 minutes. So what I need to put up here is actually the number of no. Let me see how to explain this. Okay. I'm going to put hours up here. And when I plug in, let's say if I plug in 1 hour, how many 30-minute periods have elapsed? It won't have only doubled once, it will have doubled twice in 1 hour. So if it's every 30 minutes, there are 2 30 minutes in every 1 hour. So instead of doubling once in 1 hour, it's going to double twice. And I need to put that to H. So after 1 hour, it will have doubled twice. You could also, that increases the rate. Oh, no. Okay. So you could then figure out after 1 hour, it will have doubled twice. After 6 hours, I want you to figure out after 1 hour and after 6 hours. All right, go ahead and hit pause right now. And then I want you to actually try this one. Figure out the answer here and here. Okay, I'm going to flip to the next page, which is a little different, but I mean, it's the exact same problems. All right, hit pause now. All right, so you should have gotten 132 bacteria, 135,168 bacteria, and 14,175 bacteria. That's a lot of bacteria. But I want to talk about this real quick after 6 hours, because every 30 minutes it's doubling, and there are 6 doubling periods. Really, there are 12 doubling periods. So there, it doubles 12 times. So let's talk about allowance real quickly. Some of you guys get allowance, maybe, hopefully. Hopefully you guys are doing chores to get your allowance. Let's say, I don't know, what's an allowance? Maybe $10 a week? Is that enough? I don't know. Some of you guys, the way that you eat Chipotle every day, I think you must be getting $50 a week. All right, but anyways, let's say allowance, let's say you got $10 a week. All right. But you are going to propose to your parents, I think I should have an increase by 50%. What does that mean, and how do we figure out an increase by 50%? I think many of you could just say, oh yeah, well that's this many dollars. So how many dollars do you think that would be? An increase of by 50%. Ian, what do you think? $5. Now, are you telling me that really $5 is now your new allowance? Good. It would be 15 because you're going to increase $5. So this increase by 50%, we take 50% of that, of meaning multiply. So we multiply 50% times 10 and we get 5, but then we add it to the original. So this ends up looking like 1 plus the rate as a decimal. All right. Okay, so if we did 1, times the initial amount. So the initial amount was $10, and then we need that $10, and we need 50%, so 0.5. We need 1, and we need a half of it. So 1.5 times 10 would be 15, as Ian told me. All right, class size. So what if, let's say we had a decrease in our class, my class size, let's say I had 32 kids, and they said, we are going to decrease your class size by 10%. So let's say the principal decides we need less students in class, and we're going to decrease the class size by 10%. All right, so I have 32 kids in my class. What does that look like? Well, we need to find 32. What is 10% of 32? And 10% as a decimal looks like this. 10%. I think of this as divide by 100. 10 divided by 100 is 10. With the decimal here, we move it 2 places, and 10% really equals 0.10. So as a decimal, 10% is 0.10. So I'm going to multiply 32 times 1/10, and I get 3.2. So 3.2 students less. So I can take away that 3.2. 32 minus 3.2. So how am I gonna get rid of 0.2 of a student? That means that one student gets an arm and a leg chopped off, and then so I have less students. No, not really. We can't really get rid of 0.2 of a student. So anyways, okay. How we represent this though mathematically is we started with 32. We had the initial amount of students and we subtracted 10%. To get our final amount. So let's say 1 minus 0.10 would be 0.9. So instead of saying, well, I took away 10%, we could also say, well, I'm only going to have 90% of what my class size was, which would be 32 minus 3.2, which is 28.8 students. Again, very hard to have 0.8 of a student, so we'd have to consider this in terms of real students. So either it's 28 or 29, depending on what we want to do. All right, so I'd say it was 28 students because I can't have 8/10.